Good morning, one and all, to Monday morning. This is another edition of Physics. This is the regular physics class lesson for Monday, March 23rd, 2020. Couple of notes today. Number one, questions from some students about do we need to submit our bookwork homework to you through email? You do not need to do that. We're going to hang on to that information, hang on to that. I may do some collection of some sort at a future date, but right now you do not need to hand in or email me your bookwork. But I do encourage you to do it, and here's why. Big item number two. The future of our time together is uncertain at best. So what we have to do for our own selves is to operate like we are not coming back to school anytime this year. Now, if that's the case, we've got to make use of the next few months of work together so that you could at least test out of physics if the state does not grant us the time for the coronavirus problem as being educational time. So long story short, if we come back to school, there's a possibility the state might make us go longer in school to make up those days. Or if you guys have the education through these videos and practice, you might be able to just test out of physics altogether. So I definitely want to have you do that because I don't want to have you take summer school or take the same class in the fall semester of next year. So you can just keep up with the information, and I'll find a way to track us by doing a Google form quiz maybe later this week, figure out what we're going to do right before break. All right. One other question I got from students was about 34.1, the worksheet 34.1. And it had a question to do with the lie detector test problem. Could it be that we could have two electrodes between our fingers and register a value of 300,000 ohms, but then upon a certain moistening of the skin, that resistance drops to 150,000 ohms? And the answer is yes, that is a physiological response, and I think you guys did this in part of the response on the backside of 34.1. So I'll grab that in just a second. But the physiological response of dropping your resistance from 300,000 ohms to 150,000 ohms is due to the moistening of the skin due to a lie. So a lie detector test might operate with somebody asking you a question that they know the answer to. For example, is your name John Doe? Yes, it is. Well, then there's no spike on the meter because it's reading current the whole time. Do you live at 123 Broad Street? Yes, I do. There's another question that's answered correctly. Did you file your taxes on time? And if they say yes, but they didn't, that would be a lie. And what happens is most people cannot physiologically control their responses, and a spike will occur because that will be the current rise due to the fact that they lower their resistance. Now you may be asking yourself, doesn't that raise the whole baseline of the test? And the answer is yes. So they have to start asking you questions that you know the answers to so that the curve goes back down to a baseline before they ask you another one like, did you kill that woman? Well, this is how the lie detector system works. I just wanted to make sure I addressed that from the backside of 34.1. You guys did have that question correctly, but wanted to make sure I got it to you. Okay, question for today. How does the energy compare for different types of bulbs? Is there a way to predict the energy used by different types of bulbs? And the answer is yes. Have a little think about that real fast. How does the energy compare? The answer might surprise you. It's actually in a first degree or first semester topic that we discussed called power. Power is the value of current times voltage. Now you may be asking yourself, Mr. Finn, don't we already have a definition for power? Isn't it the energy used per unit of time? Like if I ran up the stairs quickly, that would be more power than if I walked up the stairs closely or slowly. And the answer is yes, because you'd be doing the same amount of potential energy difference. You'd change your potential energy by going up the stairs, but you'd be doing it in a quicker amount of time, lower time. So running up the stairs would be more power than walking up the stairs. So let me do this with a bit of a demonstration to show you using our round bulbs and our long bulbs. Okay guys, what I have here is a setup with a battery pack with just one bulb in there. I've got my ammeter here, which shows the amount of current in the system. And I've got just one bulb, and the bulb I'm going to be using is a long bulb rather than a short bulb. So if I hook this up to there, then you can see the current is flowing in the system. Now let's see how much current we got. Looks like about 0.011 amps. Now I'm going to move that to the milliamp scale so we can get a better reading. That's just going to read milliamps. So it's actually 48.3 milliamps. 48.3 milliamps with the long bulb. Okay, so now you can see the brightness of the bulb. What I'm going to do is replace that bulb with a round bulb and see what happens to the energy that we have. So if I replace this bulb with a round bulb, you can see that there's actually no or hardly any brightness at all. You can see that it's very, very slight. I don't know if you can see that. There's a little bit of light there. But the current has changed. Instead of 44 or 47, we've got now 144 or 143. So that's quite a bit. All right, so let's do that on our big magic board and see what we can find. Okay guys, let's have a little think about this. We asked, why would the power be so different between the two bulbs? If you came up with this reason, because resistance changes a lot, and you were right on. Let's think about this for a second. We've got 1.5 volts. We're dividing by 0.0475 amps. This is Ohm's law, because V equals IR. So if you rearrange those variables, divide I on both sides, you get resistance is equal to voltage divided by current, V divided by I. So 1.5 volts divided by 0.047 amps, and that yields 31.5 ohms for the long bulb. For the round bulb, 1.5 volts divided by 0.144 amps, that's going to yield 10.4 ohms. So it looks like the long bulb is about 3 times as resistant as the round bulb. And so there's a different energy flow through that bulb with the same amount of voltage. Remember, power is current times voltage. So there's other ways to find power. We're going to talk about that in our next few episodes. But for today, let's just get an idea that current times voltage will be power, and power will indicate the energy flow through the bulbs. Okay guys, great times, and we'll see you tomorrow for more on power and Ohm's law.